In this question, they tell us that we have a mass hanging from a spring that is suspended from the ceiling and is pulled down and released. So, because the question tells us that it is pulled down and then released, basically, we are going to get, for its displacement, we should have a cosine sort of relationship. The mass then oscillates vertically with simple harmonic motion of period t. The graph shows how its distance from the ceiling varies with time t, and from the graph, we can immediately tell that this looks like it's half a cosine, and the equilibrium position is right down the center. To find the equilibrium position, we take 100 plus 30 divided by 2, and this gives us 65. So this would mean that the amplitude is going to be 35 centimeters in the positive and the negative direction. So the question then asks us what can be deduced from this graph. Now, as just explained, the amplitude is 35 and not 70, so answer A is out. For part B, the question tells us that the kinetic energy is maximum at t over 2. And we should know by now, for our simple harmonic motion, at the amplitudes, the velocity is going to be equal to 0. And therefore, the Ke is also equal to 0. Because at t over 2, the spring mass system is at the negative amplitude, this means that the Ke is 0 at this instant, and therefore option B is also out. Option C tells us that the restoring force on the mass increases between 0 and t over 4. So now, let's recall that the restoring force is going to be equal to negative m omega square x for a body oscillating in simple harmonic motion. Now, if you are only interested in the magnitude of the restoring force, we can ignore the negative sign. And basically, we can see that as the object approaches the equilibrium position, x is going to decrease. So because x is decreasing and F is directly proportional to the displacement of the spring mass system, C is also going to be out. For option D, the question tells us that the speed is maximum at t equals to t over 4, and at t over 4, we already know that it's the equilibrium position. At the equilibrium position, the speed is maximum. So therefore, option D is our answer. Before we move on to the next question, I would just like to remind you, when the displacement of an object is at the equilibrium position, the speed of the object is going to be maximum. In other words, omega x naught. However, when the displacement of the object is at either one of the amplitudes, the speed of the object is going to be 0.